Hi everyone, it's time to start lesson 2. So go into the Google Classroom and print off the note sheet titled Simplifying Radical Expressions, also the worksheet, and there's a third document called Perfect Nth Powers. You will need that too. And you may need a calculator to do some calculations. All right, so I'm gonna just get right to it so we don't waste time. Today we're going to be looking at how to simplify radicals, and we did square roots at the beginning of the year, so I'm going to review that, and then we're going to extend that to cube roots and fourth roots. So I'm going to get my whiteboard out, so just give me a second to put this down and get set up. But have your notes ready and take notes as you go. Okay, so on number 1, we are asked to simplify a square root of 50. Now we did this in the past when we were studying quadratics earlier in the year. So the rule is that this is not considered simplified because there's a perfect square that divides into 50. And if you have forgotten about perfect squares, they are on the perfect nth powers sheet that I attached. So it would be the first column that you want to look at. So you're looking at which perfect squares on the far left divide evenly into 50. So you will find that 25 is a perfect square and it divides into 50. So you're going to break up the radical into a perfect square, 25, and then there will be another radical that would be whatever 50 divided by 25 is, so that's 2. So you're going to take one radical, split it up into 2, so that one is a perfect square and one is not. Then the one that is perfect, you are going to simplify. So the square root of 25 is 5, and then this one is not perfect, so you would keep it the same. So that would be 5 square root of 2. Now if you look at the directions at the top of the page, it says that assume that all the variables are positive. So that means in this lesson you will not have to worry about the absolute value sign that you did in some of the problems last time. So no absolute value today. All right, so we're going to go to the next one. So number 2. The question is the square root of 72. So this one is not considered simplified because there's a perfect square that divides into 72. So again, refer to your power sheet. It's the first column. You want to look at all those numbers and see what divides into 72. Now this is a little bit tricky because there are 2 numbers that are perfect squares that divide into 72. 9 divides into 72 8 times. And also 36 divides into 72 twice. You always want to pick the higher of the 2 numbers. So I'm going to use 36. So I'm going to change 72 into 36, which is a perfect square, times 2, which is not. So 36 times 2 is 72. And then the square root of 36 is perfect, it's 6, and then you leave the square root of 2. Okay, so those 2 things we had done in the past. Now we're going to extend that to cube roots in the next couple of problems. So I'm going to erase 1 and 2 again. Remember, the beauty of video is you can stop and rewind. That's going to be your best friend in this class for the rest of our time together. Stop and rewind whenever you need to. Okay, so let's see. Number 3. So number 3 is the cube root of 54. So we're going to tackle this the same way as we did the other 2, except for now we were looking for perfect cubes that divide into 54. So again, you refer to the sheet that I attached to the lesson. The cubes are in the middle column. So like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. So refer to the middle column for this. So what you're trying to do is think which of those numbers divides into 54. And you may need to use your calculator, but you will find that 27 divides into 54. So you would break this up into the cube root of 27 and then the cube root of 2, because 27 times 2 is 54. Okay. And then the cube root of 27 is perfect, that's 3. And then this part is not perfect, so you would keep it the same. So you would put 3 cube root of 2. And then that would be your answer for number 3. Okay. Number 4 is the cube root of 750. So again, you're going to look at the middle column on the other sheet, the power sheet. Look for any perfect cube that divides into 750. So if you don't know, just try some of the numbers on the cube sheet. It's going to be something that divides into 750. So you will find that 125 divides into 750 6 times. 125 times 6 is 750. Now 125 is a perfect cube. The cube root is 5. And then this one is not perfect, so you keep it the same. So that would be 5 cube root of 6. Pause if you need to catch up. Okay, so for number 5, we've got the 4th root of 48. We're going to tackle this the same way, but on the power sheet, you're going to look at the last column, all the 4th power. So like 2 to the 4th is 16. 3 to the 4th is 81, and so on. You want to look for those numbers only. So we're going to think which of those numbers that are 4th powers divides into 48. So you just try some, but what you'll find is that the very first one, 16, divides into 48 3 times. So you will look at the first one, 4th root of 16. The 4th root would be 2. So you simplify that. And then this one is not perfect. So you put 2 4th root of 3. Number 5 is done. Number 6, you do the same thing with the number 162. You are looking at the 3rd column on the power sheet, and you're looking for any number that's a perfect 4th power that divides into 162. And if you try some, you'll find that 81 goes into 162 2 times. So the 4th root of 81 would be 3, and the 4th root of 2 is not perfect, so you put 3 4th root of 2. Okay, so those are the basics. You'll notice that in the next 4 problems, there are variables inside of the radical as well as numbers. So we're going to tackle those next. So on to 7 through 10. So 7, we have the cube root of 108, x to the 10th, y to the 5th, and z to the 6th. Okay. So you have to do 2 things in this problem. One is you're going to deal with the number 108 the same way that we did on the previous examples. So this is a cube root. So you want to look at the 2nd column on the sheet, the column in the middle. Those are the cubes. And you want to look for which one of those numbers divides into 108. So you just try some with your calculator, but you'll find that 27 divides into 108 4 times. So you break it up into 27 times 4. Now you also have to deal with each of these variables. 10, x to the 10th, y to the 5th, z to the 6th. So when we were doing the last lesson, I told you all to take the exponent and divide by the root 3. But the problem is 10 does not divide by 3 evenly. So x to the 10th is not a perfect cube. So what we want to do is split up x to the 10th into something that is a perfect cube and something that is not. So we're going to break it up into 2 radicals, just like we did with the 108 back here. So you want to think what power of x, the highest one you can think of, would be divisible by 3. And that would be 9. Because 9 divided by 3 would be 3. But then you're going to need a second radical and think, well, I have to have x to the 10th. So if I had 9 here, that means I need 1 more to give me x to the 10th altogether. Then you'll do the same thing with y to the 5th. 5 does not divide by 3 evenly. So you would have to think, all right, what could I break that 5 into? So if I changed it to y cubed, that would divide by 3 evenly. That would be a perfect cube. But then the other radical would be whatever you need to make 5. So if I have 3 here, I would need 2 more to give me 5 total. So 3 plus 2 is 5. Okay, and then the last one, z to the 6. 6 is divisible by 3, so that means it's already a perfect cube. You do not have to break it down. Okay, so that is the problem broken up into radicals that are perfect cubes and radicals that are not. So you're going to go back through and find all of the perfect cubes and then simplify them. So right here, the cube root of 27 would be 3. 4 is not perfect, so just leave that alone for now. This one is perfect because you can divide 9 by 3. So that would be x cubed. 9 divided by 3 is 3. This one is not perfect. This one is, though. So if you divided 3 by 3, you would get 1. So that would be like y to the first power. You wouldn't write the 1. This one is not perfect. And then the final one, that z to the 6, that is perfect because 6 divided by 3 would be 2. So you would put z squared. Now that takes care of all of the perfect cubes. So that leaves several that were not perfect. So what you will do is write the rest of the numbers inside of a cube root symbol. So anything else that you didn't use so far goes inside of the cube root. So we still have a 4, we still have that x, and we still have that y squared. So everything that's not a perfect cube stays inside of the cube root. So this entire thing, all the way here to here, is the answer for number 7. So you probably need to catch up, so pause it and start again when you're ready, or rewind if you didn't catch what I said, and we'll move on to number 8. Trying to make this video shorter than the other one. Okay, number 8, we've got a 4th root of 567, p to the 7th, q to the 12th, and r to the 10th. Okay, so again, we think of each of the parts separately. So first of all, let's deal with this number, 567. You are looking for perfect 4th powers that divide into 567. So again, those are the final column numbers on the other sheet I gave you. So you're trying these numbers to see which of them divides into 567. So you would just need to try some of them, but what you will find is that 81 goes into 567 7 times. So you'll break up 567 into 81 times 7. Then you'll go through the variables this time. You need to see if they are divisible by 4 instead. So 7 does not divide by 4, so we're going to need to break up the p. So I could change p to the 7th into p to the 4th because that is divisible by 4. But then I also need to think, what else would I need to make 7 total? So if I have a 4 here, I would have to have a 3 here in order for it to make 7 altogether. So you're going to break it up into p to the 4th and p cubed. So 1 should be divisible by 4 and 1 won't be. Okay, then you go to q to the 12th. 12 is divisible by 4, so you do not have to break up that one. You can keep it 4th root of q to the 12th for now. Okay, the last one is r to the 10th. So 10 is not divisible by 4, so we're going to need to break that one up into 2 radicals. So you want one of them that is divisible by 4. So 8 is divisible by 4. And then you want to think, well, how many more do I need to make 10? So 8 would need to have 2 with it in order to make 10 altogether. So r to the 8th and r squared together would make the 10. Okay, so everything is broken down. Now we're ready to go back through, and anything that is perfect, you go through and simplify. So like for instance right here, the 4th root of 81 is 3. This one here is perfect because 4 is divisible by 4. So 4 divided by 4 is 1. You wouldn't need to write the 1, just put P. Q to the 12th, that one's perfect because 12 divided by 4 is 3. So put Q cubed. And R to the 8th is divisible by 4, so that's a perfect one. So 8 divided by 4 would be 2. So all of those would be the perfect roots simplified. And then anything else that was not perfect, you're going to keep it inside of a 4th root symbol. So the 7 would go there, as well as the P cubed and the R squared. So that would be your final answer here for number 8. Pause and restart if you need to. Okay, number 9 and 10, these involve multiplication and division. So I touched on that a little bit in the last video, so I will re-explain in just a second. But what we learned in that video is that as long as the roots are the same, like this is a 4th root, that's a 4th root, you are allowed to multiply what is inside. So keep it a 4th root, and first multiply the numbers. So 8 times 32. You would need to get your calculator and multiply 8 times 32, and you would find that to be 256. Now you will look at your exponents. So we studied exponents last 9 weeks. So you add exponents when you're multiplying. So x to the 5th times x to the 7th would be x to the 12th if you add the exponents. And then for the y, if you don't see an exponent, remember this is like a 1 here. So y to the 1st and y to the 5th would be y to the 6th. Add exponents. Okay, so what we've done is we've combined the original two into just one radical, but this is not simplified. So now we would follow the same steps that we did in the previous couple of examples. You would first need to do something with 256. So if you look on your 4th root, 4th power sheet, notice that 256 is there. So that means it is a perfect 4th power. So you do not need to change 256. You're not going to break it up, that is. That will be perfect. Okay, then look at x to the 12th. 12 is divisible by 4. So you also do not need to break that one up. That will be x to the 12th. But what about y to the 6th power? Let's take a look at that. 6 is not divisible by 4, so we do have to break up this one. So I'm going to change it into y to the 4th because that's divisible by 4. And then I want to think, what else would I need to give me 6 total? So that would be 2 because 4 plus 2 is 6. Okay, so everything is now broken up and we can go back through and simplify all the perfect ones. So the 4th root of 256, remember that's on your table. That would be 4. This one is perfect here because we can divide by 4. So 12 divided by 4 would be 3. So that would be x cubed. This one is divisible by 4. 4 divided by 4 is 1, so that's just y. And the only one that was not perfect was this one down here, so you would just keep that under the 4th root symbol. So then that would be your answer for number 9. Pause and restart if you need to catch up. All right, so then one more, number 10. My last video was about 30 minutes long. I'm trying to cut this down for you so you don't have to spend so much time on it. So I think we're doing pretty good. D to the 9th over cube root 3c squared d. Okay, so this is the last one. This is division. So in the previous video, I mentioned that as long as these are both the same, these are both cube roots, you are allowed to divide the numbers inside. So let's do that. These are both cube roots, so I can change it to a cube root, just one cube root. You would divide the number 384 by 3, and you would find that to be 128. Now with your exponents, we learned last 9 weeks that when we're dividing, you subtract the exponents. So for the C, you would think 4 minus 2 is 2. And for the D, this would be 9, and remember this is a 1, so 9 minus 1 would be 8. So this would be another radical that is the same as this, but at least we only have one radical to deal with rather than two. Okay, so now we're going to go to this radical and simplify it like we've done on all the other problems. Okay, so this is a cube root. So you want to look at the cubes that are on the middle column of this sheet and think which one of those numbers divides into 128. So you try some, but what you'll find is that 64 goes into 128 2 times. And then you will look at the variables just like we did previously. So this one, 2 is not divisible by 3, but 2 is lower than 3. So there's no way you're going to be able to break it up and have it be divisible by 3. So you're going to just have to keep c squared as it is. And then lastly, the 8. So 8 is not divisible by 3, so I will need to split that one up. So I'm going to change that one into d to the 6th. And then I want to think, what else do I need to make 8? So 6 plus 2 would be 8. 6 plus 2 is 8. So that last one is d squared. Okay, so now we're ready to get our final answer by simplifying all the ones that are perfect. So the cube root of 64, look on your chart, that's 4. This one is not perfect, so just move along. That one's not either. This one is divisible by 3, so you would put d squared. And those are the only ones that are perfect cubes. So everything else that's not perfect, you're going to keep it inside of a cube root symbol. So we would still have the 2, the c squared, and the d squared. So then this would be the final answer for number 10. All right, so we're done. This time I got the video to 22 minutes, so it's a little bit shorter. That's what I was trying to do here. So again, I'm going to give you an assignment, and I want you to work on that and submit it just like before. So I miss you guys. I love you. See you soon. Bye.